Hi, I'm Paul. We're doing Leetcode must know interview questions. Today's challenge is max points on a line. We've been doing math challenges for a while. I think this is the last must know math challenge. Let's see. Given an array of points where points at I equals x sub I, y sub I, where that represents a point on the xy plane, return the maximum number of points that lie on the same straight line. Okay, so what we're getting is an array of two-element arrays. Now, I think what makes this hard, and to be honest, I don't really know an elegant, like linear algorithm for this. I think it's going to be an n squared algorithm. It's going to be actually, slightly worse than an n squared algorithm. And I'm wondering if there is, a more elegant solution to it because of this constraint here that we're not going to have more than 300 points, okay? It's not one of these problems where we might have an array length of 2 billion, okay? So with 300 points max, a sort of brute force algorithm is okay here. All right. So here's a couple of examples. 1, 1, 2, 2, 3, 3. We have those points. The maximum number of points on a line would be 3. Those points are all on the same line. Here we have 1, 2, 3, 4, 5, 6 points. It looks like these 3 across here are on the same line, but then these 4 are on the same line. So the output is going to be 4. All right. So how are we going to do this? Well, what we can do is starting with the first point, we can compute the slope between that point and every other point in the array. And points with the same or pairs of points with the same slope. How do I want to say this? Pairs of points with the same slope will be on the same line, so we can count them. We can keep track of them and count them, and then we can move to the second point, compute slopes with the subsequent points. So it's basically a nested loop. Points with pairs of points with the same slope are on the same line, or they're on parallel lines, but since we're starting at a fixed point and using that to compute slopes, then there aren't going to be any parallel lines. All right. I think the thing that makes this hard, elevates this into the hard category. Well, I guess one is keeping track of, finding a good way to keep track of the points and or to keep track of the pairs of points and their corresponding slope. And the other thing is that we're just going to compute slopes based on coordinates. So rise over run. So we're going to take x. Let's see. Rise would be the y. So we're going to take y2 minus y1. We're going to take x2 minus x1. The slope is y2 minus y1 over x2 minus x1. But it's possible that we get slopes that are the same but don't have the same denominator. Like we might get a slope of 4 over 2. We might get another slope of 2 over 1. Those are the same. The slope is the same, but the numbers aren't the same. So we've got to do a little extra work to put those over a common denominator. I can't think of anything else to say about this before we start on the implementation. So let's give it a try. All right, let's do this. Let's start with num points. This is just a convenience equals max points. I'm sorry, not max points. It's called points equals points dot length. That's just so we don't have to keep referencing points dot length. We also need a variable to hold our answer, and we'll call that max points in line. Let's initialize it to 1 because it has to be at least 1, even if there's only 1 point. And actually, what is the constraint on points here? Okay, so the array is going to contain at least 1 point and as many as 300. Okay. So even if there's only 1 point, the lowest max point in line that we can get is 1. All right. So now we go into the for loop. For int I equals 0, I less than num points I plus plus. All right. So this is going to be the point that we use to compute slope. We're going to use this point for every other point in the array. This will be the first time through. This is the first point in the array, and we're going to calculate the slope from this point to every other point in the array. So let's call these variables x1, which equals points at index I 0, and let me copy that. Whoops, it's not quite what I wanted to do. And y1. Y1 is going to be points at I index 1. Okay. Now, for this point, we want to have a map. It's going to map, how do I want to say this? It's going to map slopes to a count. How many times does that slope appear? So let's do this. Let's say a map of string to integer line map equals new hash map. All right, I did say this is mapping slopes. It counts. Why is slope a string? Well, really, if we went through the whole computation of slope, it would be a number, but we're not doing anything numeric with it. So we can just put the rise and run in as a string, which is my preference. You know, if you have numbers but you're not really treating them numerically, we just need it for a key. I guess it would be similar to you know, a zip code, for example. There's no reason to store that as a number. So we're going to store the slope represented as a string. All right, now inner loop. We're going to handle all the other points. So j is going to start at I plus 1. It is going to go to num points j plus plus. We need x2 and y2, so I think we can just grab this, put it here, indent it a little bit. y2, this is going to be at J0 and J1. Okay. Now we can compute rise and run. Let's say int. I don't want to use rise and run. Let's just say delta 1. No. Let's do delta x, which is actually the run is going to be x2 minus x1. Whoops, no. And then delta y will be y2 minus y1. All right. If we went ahead and did the computation, for, the actual computation of the slope, it would be delta y over delta x. I really don't want to do the division because we're possibly going to get into rounding error or something like that. I just want to know what is delta x and delta y. But I also want to be sure that we are considering things that are equal as actually being equal. So if delta y was 2 and delta x was 1, that really is the same as delta y being 4 and delta x being 2. The slope is the same. So we need a greatest common divisor here to reduce these if possible. And I think for now, let's just do this. Let's do this. Let's say int GCD, greatest common divisor, equals GCD delta x delta y. We'll write the GCD. We'll write the GCD function. It's a simple function. It's the the Euclid GCD algorithm. All right. Now GCD. Okay. All right, so we can go ahead and assemble the slope key. And as I said, we're going to do that as a string. Let's say string, okay, we did the GCD, so now we can do string slope key equals delta x divided by GCD. That'll be an integer, plus some kind of separator character plus delta y divided by GCD. That's the slope key. And then into the line map, our map, we're going to put the key and the count. So line map dot put, we'll put slope key, and we'll put line map. We'll do a get here and get the current count for the slope key. Now it's possible that the slope key won't be in the line map yet, but Java provides a workaround for that. So get the slope key, get the slope key or the default, which is 0, and add 1. All right, now we have a count of how many times have we seen that slope. Okay. And what we want to do is update, if necessary, max points in line. Okay, max points in line equals math dot max points in line, or line map dot get slope key plus 1. Okay, why are we adding 1 there when we already added 1 up here? Well, that's just a count of how many times that we have seen the slope. Now, the plus 1 here is for the number of points on the line, so that's adding 1 for the initial point. That is, if we come through here the first time, we get the x1, x2. We come through, we look at the next point. I'm sorry, we have x1, y1. We come through the second time, we get x2, y2. We compute the deltas, we compute the slope key, and now we say, all right, we've seen this slope once, but there's 2 points on the line. The initial point and this second point that we just found. So that plus 1 is for the original point. Okay. Once we're done with the loop, we will return max points in line, and we need one more thing, which is the GCD function. So that'll return an int GCD int. We could call this x and y, but I don't know. I think that sort of confuses the issue a little bit. But you can call it x and y if you want to. Int a b, so the algorithm is return if b is equal to 0, then we have found the GCD and it's a. If otherwise, we'll do a recursive call, GCD b and a mod b. I'm not going to go into detail on that, but you can just check out the Euclid GCD algorithm. All right, that's all I can think of to say about that. Let's try running it. Something happened. All right, accepted. Let's slide this over. And make it a little bit wider there. Submit. 35 seconds. All right. So what did we get there? I mean, that was the most common solution time, but it does look like most of the solution times were better. So there may be there may be a faster algorithm for this. I'm gonna I'd encourage you to maybe check some of the solutions here, see if there's something faster. I thought the brute force essentially method would be adequate in that they're only going to give us 300 points. So we do n squared, we're fine. All right, so that is max points on a line. Please feel free to like, subscribe, comment, and see you next time.